I will show you two different methods for tackling this problem. The first method is amazing because I will use four different theorems. I will use chord-chord power theorem, the perpendicular bisector of a chord, the Thales theorem, and everyone's favorite Pythagoras theorem. Now we have the following problem. We are given a circle with this chord of the length of 13. Then there is this line perpendicular to it with the length of 6. And then we have another line which is perpendicular to it and it has the length of 18. We have to find the radius of this circle. To solve this problem, I will first draw this line, which will be parallel to the line of the length of 6. So these are the right angles, and it has the length of 6. We can now observe this rectangle with the length of 6 here, while this side here also has the length of 13 as it is parallel to this side of the length of 13, and this line here, the side of the rectangle, has the length of 6. Now, since this entire line has the length of 18 and this side of the rectangle has the length of 13, this part right here of the line has the length of 18 minus 13, which is 5. Let's continue this line of the length of 18 on the upper part all the way until it intersects the circle to complete an image. We can label the length of this piece as x. Now we are going to use a perpendicular bisector of a chord theorem. And for that theorem, I need a circle. Now that theorem states that a line drawn from the center of a circle to a chord. We have a chord and we have a line drawn from the center of a circle to a chord. It is perpendicular to a chord. This line has the property to bisect the chord, which means that it will cut the chord into two equal halves. Let's now draw this perpendicular bisector line from the center of our circle. It has a right angle here and it has a right angle here. Using the theorem just mentioned, both of these parts will have the length of 13 over half. This part and this part right here. Of course, the same applies for this chord, and this part will have the length of 13 over half, and this part here as well will have the length of 13 over half. Let's now use the perpendicular bisector of a chord theorem once again in this entire chord. As you can see on the upper part, we have 13 halves and plus this x. And that has to be of the equal length to the lower part of this chord, which is 13 over half plus 5. And that is going to give us the value of x to be equal to 5. At this point, we can apply the chord-chord power theorem. Now, a little explanation for the chord-chord power theorem. It states that if we have the two lines like this in a circle, dividing this circle into four pieces, 1, 2, 3, and 4, and this is any angle. It doesn't have to be a right angle. I am going to label the sides as A, B, C, and D. And the chord-chord power theorem states that if you multiply the lengths of the two parts of one chord, so A multiplied by B, that has to be the same as multiplying the parts of the other chord, which is C multiplied by D. Now let's apply this theorem into our problem. Let's draw a line like this. Now this is the piece which we don't know the length of. So let's call it the length of y. We are going to use the chord-core power theorem on these lines. Now let's name these special lines that we are working with as A, B, and C, D over here. And those two lines we are going to apply the chord-core power theorem on. What we are going to get is that this length here, which is 18, multiplied by this length here, which is 5, has to be equal to this length here, which is 6, multiplied by this entire length here, which is y. And that is going to give us that y is equal to 18 multiplied by 5 over 6. 6 and 18, that is going to remain 3. And we finally have that y has the length of 15. So this is 15. What we can now do is calculate the length of this entire chord CD. It has the length of 6, which is this part, plus 15, which is this part right here, and totally that is 21. On our picture here is one more important dot, and that is this dot here. Let's call it E. Let's now connect the dots E and D. As you can see, we get this right-angled triangle CDE with a right angle here at dot C. As you can see, this line ED passes through the center of our circle right here. And that is not a coincidence. The Thales' theorem states that if a triangle is formed inside of a circle with one of its sides as a diameter of that circle, then the angle opposite of the diameter is always a right angle. As we have all of this, it's clear that ED is a diameter of our circle and it has to pass through the origin. If we say that our circle has a radius r, then the diameter will have the length of 2r. At the end, now we are going to use everyone's favorite right triangle theorem, the Pythagorean theorem. So we have that 2r squared is equal to 13 squared plus 21 squared. What we have now is that 4r squared is equal to 169 plus 441. So 4r squared is equal to 610, and that means that r squared is equal to 610 divided by 4. That is going to give us the result of 152,5. The r now has the value of a square root of 152,5, and radius is approximately of the length of 12,35. And this is the final answer to our problem. Now I want to show you a second method for solving this problem. This time we are going to use analytical geometry. We are going to place a Descartes coordinate system with an origin at this point here. So we have our x-axis right here, and we are going to have y-axis perpendicular to it at the origin. So this is the y-axis. This is the origin 0, 0. As you can see, this circle which we are looking at goes through the origin. This dot, which has the coordinates 0 and negative 13, also is on the circle. This dot right here has the coordinates of 6 and negative 18, and it is also on the circle. Let's say that the center of our circle is at dot xy, which we don't know the coordinates of at the moment. Distance from the dot xy to the origin of our coordinate system 0, 0 is equal to r as a radius. The distance from the dot x, y, which is the center of the circle, to this dot right here, which has the coordinates of 0 and negative 13, is also r. And the distance from x, y to this dot right here, 6, negative 18, is also equal to r. Now the distance is defined as a square root of x minus 0 squared plus y minus 0 squared, and that is equal to r. In the second equation, we get a square root of x minus 0 squared plus y minus negative 13 squared is equal to r. And in the third equation, we get a square root of x minus 6 squared plus y minus negative 18 squared to be equal to r again. What we have from the first equation now is the equation x squared plus y squared is equal to r squared. In the second equation, we get that x squared plus y plus 13 squared is equal to r squared. And in the third equation, we get that x minus 6 squared plus y plus 18 squared is equal to r squared. And we have to solve this coordinate system for x, y, and r. Let's solve this system of equations. So we have x squared plus y squared is equal to r squared. The second equation is x squared plus, and when we expand this, we get y squared plus 26y plus 169 to be equal to r squared. And when we expand the third equation, we get x squared minus 12x plus 36 plus y squared plus 36y plus 324 to be equal to r squared. We have x squared plus y squared from the first equation here in the second equation, so we can plug in the value for r squared there. And we have 26y plus 169 to be equal to r squared. The r squared and r squared are going to cancel out, and we get that y is equal to negative 169 over 26, and that means that y is equal to negative 6,5. We have x squared plus y squared from the first equation also here in the third equation, so we can plug r squared there immediately. We have negative 12x plus 36 plus 36y, and y is negative 6,5, so that is 36 multiplied by negative 6,5, and plus 324 to be equal to r squared. R squared and r squared are going to cancel out. We have that negative 12x is equal to negative 36 plus 36 multiplied by negative 6,5 and minus 324. That is going to be equal to negative 360 plus 234. Which is equal to negative 126. So x is now equal to 126 over 12, and that means that x is equal to 10,5. When we return the values of y is equal to negative 6,5 and x is equal to 10,5 into this equation right here, we get that r squared is equal to 10,5 squared plus 6,5 squared, which is equal to 110,25 plus 42,25, which gives us 152,5. Well, r is then equal to the square root of 152,5, and that means that r is approximately 12,35, as we got before. So thank you for watching. I hope that you have enjoyed this problem, and I hope to read your comments. Please leave a like, share, and subscribe. And at the end, I recommend that you watch this video next.